Hello, students. We just kind of want to continue with properties of exponents, and we want to talk about what happens when you have the power of a power. So in a case like this where you're raising a power to another power, and so you see here that you have the base A, and it already has a power. But you're raising this whole thing to another power. With something like this, what you'd want to make sure you do is you'd want to multiply the exponents. So something like that would be written like this: A raised to the m times n power. Part two of that, if you had something that looked like this. Right here you can see here that you have this whole expression, and again you've got a power here, or exponent here, that goes with the a raised to the power of m. You have another exponent here, b raised to the power of k, and then you have this whole expression raised to this power. What you would do in a case like this is you would still multiply your exponents, but it's almost like you would distribute the outside exponent and multiply it times each of the exponents times each exponent on the inside. Remember, you cannot simplify the inside, or what's inside the parentheses here, because those two bases are not the same. But again, the way that this would look is like this. So again, you'd multiply and you distribute that outside exponent to the first one. So it'd be a raised to the m n power, and it would be b raised to the k n power. And again, of course, I'm going to give you some examples to make sure that you have seen how this works out when there are numbers involved. Okay, so let's say that we had an example that looked like this: w to the fifth power raised to the third power. You've got a power raised to another power. So again, what we said is that you have to multiply your exponents. Now, of course, a lot of you can just already tell me, based on me telling you to multiply your exponents, you can tell me what this should look like. But again, I'm just going to sort of give you something else that might help kind of reinforce what I told you about that. So again, you guys remember with exponents, what that means is that you technically have repeated multiplication, right? For example, if you had a number squared, that means that number is multiplied by itself twice, right? So if this is raised to the third power, okay, that means that technically this right here is multiplied by itself 3 times, right? Because that's what it means for something to have an exponent, right? Repeated multiplication. So to kind of help reinforce what I've told you here, just going to write it out like this. So if you have w to the fifth, w to the fifth, w to the fifth, well, we just talked about that product property with exponents, okay? Even if you didn't remember, if you did not even remember what I've just now told you about multiplying these two exponents, if you just write it out like this, okay? Here you have 5 w's, you have another 5 w's, and you have another 5 w's. Now, I could sit here and I could write out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and you could see that you have a total of 15 w's. Again, but again, the concept here is that you multiply your exponents. You have a total of 15 W's when that happens, okay? And so this winds up being W to the 15th power when you multiply those exponents. So, with another example, with an example like this one here, here you have, again, more things on the inside here that are raised to this power. And so, with something like this, just kind of be mindful that it's this part here multiplied by itself 5 times. What we are going to do is we're going to distribute this exponent here. And so again, just like if you had this multiplied by itself 5 times, you'd wind up having the -2 multiplied by itself 5 times. That means that will be -2 raised to the 5th power. So again, you distribute the exponent, the outside exponent, to the inside exponents, to all inside exponents. And remember, guys, that technically the exponent for this -2, or the exponent for the 2, is technically a 1 right here, right? So that's 2 raised to the 1st power. So if you were using what I told you here, that means that you'd be multiplying this outside exponent 5 times 1, okay? Which winds up being to the 5th power. We also have the x to the 3rd power, and we have to raise that to the 5th power. And we have the y. What's the exponent for the y? Technically, the exponent for the y is 1. Y to the 1st power raised to the 5th power. Okay, and when we put all of that together, after when we simplify all of that, -2 raised to the 5th power. Again, if you multiply -2 times itself 5 times, -2 times -2 times -2 times -2 times -2 5 times, you'll wind up having -32. Okay, and then if you'll treat this part with the x to the 3rd raised to the 5th power, you can treat it just like we did in example 1. Okay, you multiply those exponents. You have a power raised to a power, and that's going to be x to the 15th power. And then this part here is just going to be y to the 5th, of course. And this would be the result here. So, let's say that for the 3rd example, we had something that looked like this. And so it may look a little bit more complicated, and it might even be a little bit more complicated. But again, we're using the same concept. So here you see one expression here that's raised to the 3rd power, multiplied times another expression raised to the 2nd power. And so with this, you'd want to deal with each expression just like we did in number 2. And so again, if you raise that -3rd, if you distribute that exponent to each of the exponents on the inside, again, right now the exponent for the 3, or for that -3, is 1. That's -3 raised to the 1st power. And so we want to, again, distribute that. If you can kind of do this where if you remember the whole multiplying the exponents or distributing, and you know 3 times 4 gives you 12, you can go ahead on and write out m to the 12th power here instead of writing what I'm writing, of course. But I'm making an emphasis about distributing that exponent. Okay, so that first part here, raised to the 3rd power, and then the second one, raised to the 2nd power. If we distribute this 2 to every exponent over here, 2 raised to the 1st power, because technically that exponent's 1, and it's raised to the second power here. N to the 6 raised to the second power. O to the second power raised to the second power. And then P raised to the second power. So we're distributing all of that. Okay, so negative 3 raised to the third power. That is negative 27. Okay, m to the fourth raised to the third power. That's going to be m to the 12th power, because again, here you have four m's, and again, if you write that out 3 times, you'll wind up having a total of 12 m's, or if you multiply these exponents, a power raised to a power. Here you'll wind up having O to the 27th power. Okay, and here you wind up having 4 into the 12th, O to the 4th, and P squared. So what you can do here is remember that you need to multiply your coefficients. And so again, I'm just going to put these parts beside each other. Negative 27 and 4. The m is all by itself. Did I forget something? I sure did. You guys let me forget that, didn't you? It's okay. The n there. I know you didn't let me forget that. I didn't see it or overlooked it, but that's okay. N to the third power. And O to the 9th raised to the third power. Felt like I was forgetting something. There we go. Knew I was forgetting something there. All right. So again, guys, I had overlooked the n. Okay, my eyes. I've been tired. I'm tired. I've been here all day. So I had overlooked the n earlier. So that is n to the third power. N to the third power. And put that together with this n to the 12th. And we put the O's together, O to the 27th power, and O to the 4th power. And P is all by itself. Okay, so with all of that together, again, you deal with the parts that have the same base. But again, you multiply your coefficients first. Negative 27 times 4 gives you negative 108. Negative 108. Okay, the m doesn't have anything to go with. These two n's, again, remember with the product. Remember with that product, n to the third times n to the 12th. You add your exponents. There's a total of 15 n's there. For the O's, putting together the 27 and the 4, there's a total of 31 O's. And then P squared is the thing that's left here. And so this would be how this would wind up looking. Okay. I do hope that this has helped with using this power of a power property. I've tried to give you a variety of different types of examples to look at, from simple to not so simple. Well, that's it.